demo, we will be rendering an SVG on-chain, and we are going to be using a feature that is unique to RSK, which we are able to use an on-chain method to get the Bitcoin block number. And we'll also get an RSK block number using, standard thing that's available in Solidity that maps to an opcode. And we'll use all of that to create an NFT using an OpenZeppelin, stock standard library smart contract, just like you probably do in Ethereum. Okay, so for those of you who've done the thing at the beginning where you set up your MetaMask or whatever browser wallet and connected it to the RSK testnet, you'll be able to mint your own NFTs at this URL. So scan this or just type out on-chain animated SVG nft.netlify.app. And you'll be able to see. I'll show everyone on screen shortly. And for those who don't, you'll be able to just view. You don't need to have gas necessarily. You just need to be connected to the RSK network. And yeah, this is what it'll look like. So let's take a look. All right, awesome. So you can see here I'm connected to. I'm just wondering if that's big enough for everyone to see. Is the screen size good?
Yeah, that's good. Yeah.
Okay, awesome. All right, so I'm connected to MetaMask on the RSK testnet. You can see that here. Right, you just have to click on that thing and go down the list, go to RSK testnet, select that. And then you also have to have a balance in testnet RBTC, and that will enable you to interact with this the create new NFT function. So I've already been set up, obviously. So what I'm going to do is I am going to create a new NFT by selecting some colors. As you can see, I'm not very proficient with CSS, so this is a bare bones selection. So let's go with some sort of cyan color and some sort of orangish color. And then I'm going to press create new NFT. That'll trigger a MetaMask pop-up, which you can see over here. It looks pretty much the same as Ethereum transaction. In fact, at this stage, it's actually identical. You can see that here. I'm calling the create function of the smart contract. I'll show you all that later, and we'll send in 2 strings. And this is the hex data that I'm sending in. And I'm just going to say confirm. So what's happening is that transaction has been sent to the RSK network, and we're just waiting for that to get mined. So a transaction's been added to a block, and we're waiting for that block to get mined and confirmed. It'll take up to 30 seconds. So I'm just going to open that on the RSK Block Explorer. So if you're familiar with Etherscan or one of the other block explorers, this is pretty similar. You'll see a transaction hash, see a from and to. The to is the smart contract address of where this particular smart contract has been deployed. You can see that here. So test block clock NFT, which implements ERC-721. Yeah, you can see that. And it looks like that has happened, right? So let's just take a look at this. Contract call has been successful. You can see the same data. This should match what you just saw in the MetaMask transaction. I haven't transferred any amount to the smart contract itself. I just paid the gas for the execution. That's it. And let's take a look at the logs. So these are the events. Let's take a look at the transfer event. I've got 3 parameters. Token ID is the final one. That's 0xD. What's that? Hexadecimal. 9, 10, sorry, 10, 11, 12, 13. I think it's 13. Let's see if that gives me that. So what I'm doing now is I'm going back to my DApp and I'm pressing get NFT by token ID. Oh yeah, that's right. So I got the same I got the same colors that I selected earlier on, this sort of cyan color and sort of orange color. You'll see what happens later on. Actually, let's just pop up the DevTools console. I'm going to make this a bit smaller here so that it fits. Every time I make a call, it'll log the SVG that's being rendered on chain onto the screen. And as it moves, you'll see the RSK block sort of ticks, and it comes and it moves, and then it just renders a new version. So the Bitcoin block is much smaller. It'll take, it depends on the merge mining hash rate, right? So if a Bitcoin block gets mined, every single block on Bitcoin gets merge mined, then you'll see one happen every 10 minutes. Otherwise, on average, we're expecting every 20 minutes this to move by 2. That's the side effect or consequence of merge mining without a full percentage hash of the hash power merge mining in. But yeah, anyway, you can see this sort of ticking along as you go along. But while that's happening, I will give you a quick overview of the code. Let's start. I think the best place to start would be truffle config. So this is probably where the biggest difference between Ethereum and RSK is. So I'm not going to do a whole coding live demo. We don't have enough time for that. Only 15 minutes total, probably running over already. But essentially, it's going to be pretty much the same as a truffle config, with the main difference being that you need to do this extra RPC call to get something called the minimum gas price. So you get the latest block number. And let me just make that a bit bigger. Is that visible for everyone? The text size is fine. Yeah, all good?
Yep, all good.
Awesome. Okay, so you get get block by number. You just issue a call request on the command line, and then you pass that block to get minimum gas price. So this is one of the differences between RSK and Ethereum, is that we have this additional thing that comes back in the RPC endpoint. Basically, in Ethereum, there is no minimum gas price, but RSK does have one. So yeah, you just have to make sure that it's more than that minimum gas price whenever you issue a transaction. So yeah, get that, and then you're good to go. The rest of it is pretty similar to a network configuration. So let's take a look at testnet, which is the one that we're connected to. Make this a little bit bigger. We're using Truffle, tasty wallet provider, nothing fantastic or new here. What is different is this, right? So we use a custom polling interval because the block frequency is lower, and we're also connected to the public node, which has rate limiting that is less generous than Infura, let's just say. And yeah, we also have a custom network ID. This is specific to, you'd have to do this for, say, on Ethereum, you'd configure a different network ID if you're connecting to Rinkeby versus Robston or whatever, or the mainnet, right? So same way Ethereum testnet and, RSK testnet and RSK mainnet have a different network ID as well. And then also another polling interval for deployment. So this is when you do truffle migrate, it'll fix that. So yeah, a few minor differences, nothing major. All right. Then let's take a look at the part which drives the, we were lucky. So the Bitcoin block did tick over just now. So remember, it was over there. So it just ticked over here. So we were lucky. If we had to wait for 20 minutes, it'd come after. Cool. So let's take a look at what actually drives this being able to move, right? We've got the bridge, right? And that has, we don't have the smart contract implementation because this is built into the protocol of RSK itself. So we've essentially got a smart contract interface, right, that you just initialize it against this well-known address. And what we're doing is we're just calling this method over here to get the Bitcoin block number, essentially. Yeah, and then let's see how that's being used. So let's skip all this first and just go to this function, get block RSK and Bitcoin block numbers, right? I might need to make this a little bit smaller so that you can see it all on the screen at once. So we do get bridge, which is implemented. where is it? Over here, right? So this well-known bridge address number that's baked into the protocol is initialized using that bridge interface you saw earlier on, and that allows us to call this method on it, right? This get the Bitcoin blockchain best chain height method to get the Bitcoin block number, and likewise we are getting the RSK block number, which is the one that's driving the position of this smaller leaf, using block.number, which is essentially the exact same Solidity code that you'd use to get the Ethereum block number were you to run this on Ethereum, right? And it returns that. And then what happens is the magic happens over here with the rendering. It's just basically concatenating a bunch of strings, which is kind of hard to read here, but this is actually the main idea, right? So you've got this SVG, and what it does is it replaces these numbers in the rotate thing with whatever the angle it has computed for the rotation of those leaves. Yeah, so that's pretty much how the on-chain rendering is happening, and it's animated because of the block numbers, the ticks are driving it. Okay, and the other thing I kind of just wanted to illustrate is how easy it is to create a token, in this case, a non-fungible token or an NFT, using stock standard Ethereum implementations of smart contracts. So OpenZeppelin is something many of you would have heard of if you've done any Dapps development before. So they maintain a list of smart contracts that are quite often used as reference implementations or baseline implementations to extend. And this is exactly what I've done. So I've taken the 721 implementation, which is a non-fungible token, and then I've done, contract blah, and it extends ERC 721 from OpenZeppelin, and bam, suddenly I've got an NFT, right? So I just need to initialize it in my constructor, and when I press create new NFT, what's happening in terms of smart contracts is this, right? So it's just calling this function here, save mint, that comes from the OpenZeppelin standard implementation. And then I'm just doing my own custom stuff over here to, to store the different colors, one for the Bitcoin leaf and one for the RSK leaf, inside the storage area of the smart contract, so that when it's being rendered, it can just retrieve it from the storage or the persistent storage of the smart contract. So yeah, that's the demo. I hope I didn't lose anyone. I'm just going to pop back in here to see if there's any questions. Yeah. Okay.
Yeah, and for anyone who has questions or thought that was too fast, we're going to be recording this, and then we're going to be uploading this on YouTube, so you guys could go back and watch it over and over and over again. No problem. Yeah,
exactly. So I was toying with the idea of doing a dedicated sort of live demo of recreating this block clock animated SVG NFT, all the way from start through finish, because I kind of just blitzed through it over there in about 10 minutes or so, or at least that's what the clock leads me to believe, the block clock, if I may. Yeah, so if that is of interest to everyone here at this meetup, then great. We can certainly arrange that. Yeah, amazing. So yeah, let me know in Twitter or reach out directly to Mike, whatever, if that's of interest. Cool. So now it's time for the questions.
Yeah, so we have some pre-asked questions that we've put on all of our social medias. That's why everyone should be following us on social media, Twitter, Facebook, Telegram, the like. And all these questions will be receiving some free Riff tokens. So they're getting paid. So in the future, we're going to be asking questions ahead of time. Best questions get picked. And we have 5 lucky questions today. So Brendan, I'll let you go ahead.
Yeah. So I just wanted to quickly highlight, where was that slide? So the Riff tokens that Mike just mentioned are utility tokens that you can use to pay for apps and services that are part of the RSK infrastructure framework. That's where the value derives from. And yeah, like for example, if you wanted to buy your own domain name, like yourname.rsk, Riff tokens will come in handy for that. So yeah, just wanted to highlight that. Okay, cool. So let's dive into the questions. So we've got a question from Melissa. Can you please explain the concept and process of merge mining? So I think I sort of very briefly touched on this in the original description. So just to go into a bit more detail. So a certain percentage of Bitcoin miners, they take information from RSK network. So they run both a Bitcoin node, and they also run an RSK node. And then the information that comes from the RSK node, they use that in a certain set, following a certain set of rules, and they create this thing called an RSK tag, and then they attempt to insert that into a Bitcoin block in the data field, right? And then the RSK network obviously listens for this and sees who inserted the RSK tag, and gives that particular Bitcoin miner a additional reward. So the Bitcoin miner is sort of like earning on both sides of I should say on both networks, right? So they're earning the normal Bitcoin mining reward for mining a block. So they get the block reward and whatever the transaction fees are, that goes to their, their Bitcoin Coinbase as part of their, the block that they've submitted. So they get that, right, denominated in BTC, right? And then on the other network, the RSK network, because they've included this RSK tag, they also get compensated for that with the RSK reward that's determined, or denominated in RBTC, or smart Bitcoin. So they get both things. So this is essentially the economic incentive, and also the central theme of how merge mining works. It's a lot more complicated than that. But yeah, that would be an entire presentation in itself. That's how I'd summarize it. But just to sort of, if you want to look at all the technical details, the RSK white paper is the best place to go. Also, if you go to the developers portal, the RSK dev portal, which I think I linked to earlier on, you can go check out we have a whole series of articles on something called Armadillo. Armadillo is a monitoring alerting system that we have. That is not part of the RSK protocol itself. It sits outside of it. But if you understand how Armadillo works and what it checks for, you'll understand merge mining, how RSK implements merge mining a lot better. It's a very useful tool to understanding it. So I encourage you to check that out as well. Okay, but in terms of like how this actually works, you have a certain number of blocks that happen, and then they're secured by the Bitcoin network because an RSK tag happens. So if we got roughly 50% of Bitcoin miners merge mining on RSK, then you've got roughly 20 blocks on RSK per one block on Bitcoin, right? On average, every 40 blocks that occur on RSK would be expected to be secured by the Bitcoin network. So that's the level of security that you have, right? In terms of like the most immediate version. Yeah. So I hope that explains the concept of merge mining on RSK. Yeah, and like I said, it's a lot more complicated, and I'm not doing it full justice. I'm just sort of like giving a brief intro. Moving on. So Leroy and Maurice, both of them asked almost word for word the same question. What makes RSK the safest smart contract blockchain? So, interesting. I think I made this slide earlier today. So yeah, you can see that it fluctuates, right? So I think in an earlier slide I had 53%, and then in this latest slide I had 57%. So the Bitcoin hash rate, it fluctuates, and which miners happen to be mining that particular hash rate also fluctuates, so it goes up and down. Never mind that, screenshots are static, but this website always gives you the most accurate information. What I'd like to point out is that no other blockchain has such a high hash rate securing it. 73 exahashes is pretty high, and as far as we know, no other smart contract platform has that high of a hash rate. So that's the sort of the mathematical reason why we consider ourselves to be the safest smart contract blockchain, because it's just got the highest hash rate securing it. All right, and we've got a question from Kim. How will I ensure that my account in RSK is secure? So I will answer this question not specific to RSK, but in more general terms, like how will you ensure that blank blockchain, so any blockchain account, is secured, right? So what is an account on a blockchain network, right? It's a private key and a public key, often managed using wallet, which can be some sort of software that runs on a dedicated device, like a hardware wallet, or a software wallet, which is something that runs on a general purpose device, such as your PC or laptop or phone, right? So the main thing is to make sure that only you hold or access your private keys. If anyone else has access to your private keys, then you have exposed a vector of attack for your account, right? So if you store your crypto or your tokens or whatever, on a centralized exchange, and they hold your private keys for you, you don't actually, your account with them is only as secure as you can trust that exchange operator, or for them to not get hacked. So there's a Bitcoiner maxim, trust but verify, and several variations thereof. But essentially, it boils down to hold your own private keys if you want to hold your crypto and keep it safe. There's also a concept of hot wallet versus cold wallet. So this is the idea where you keep two, I guess, separate pots of money, right? One is the stuff that you never touch, and one is the stuff that you want to transact with. So by keeping them separate and using different levels of security versus convenience trade-offs between them, you're able to keep the majority of your assets, I guess, safer, and the stuff that needs to be transacted will be, a smaller amount. Same reason why you keep the majority of your money in a bank, your fiat money in a bank, and a minority of it in your wallet. The other thing I would say is assess the protocol level security. So this is where I can get a little bit RSK specific. So if you're on a blockchain where it's easy to subvert the consensus protocol, and you see that in a lot of like the smaller and newer blockchain networks, where you can a hacker could potentially like spend a few $1,000s and on Amazon or something, and essentially run a bunch of nodes and take over more than 50% of the hash rate of that particular network, and then boom, protocol level security is completely obliterated. Now that is virtually impossible on Bitcoin and on RSK and on Ethereum and many of the other more established bigger blockchains. But yeah, it's not something that you would that you would see in every single blockchain by default. Yeah, just because you've got proof of work, that isn't a be-all and end-all. It's also how much hash rate is securing it, or if you've got proof of stake, how much asset value is securing it, etc. Another thing is to basically be careful yourself. So we call these like best practices for security hygiene. So for example, you'll see here that I have my MetaMask wallet, and you can bet that this is not my actual crypto address. This is specifically created for demonstration purposes, because I do demos quite a bit. I keep everything separate, and that's an example of a security hygiene best practice. Hot and cold wallets, that's another security best practice, etc. There are so many of them out there. So find out what they are and stick to them, and that's one of the things that will ensure that your account is secure. All right. How many transactions per second can RSK do? So I guess this is a question of scalability. So I like to think about it not just in terms of transactions per second, but also in terms of latency. So throughput is measured in transactions per second, and it's 10 transactions per second on RSK. This is faster than both Ethereum and Bitcoin. In terms of latency, so this is essentially how long can you potentially wait until your transaction is being mined. And this is largely determined by the block time, right? What's your average block time? So in Bitcoin, it's 10 minutes or 600 seconds. In Ethereum, it's 15 seconds. RSK is 30 seconds. So it's slightly worse than Ethereum, a lot better than Bitcoin. Yeah, that's the trade-off you have. Worth mentioning that we also have something called Lumino. So Bitcoin is layer 1, and RSK, we see ourselves as layer 2 to Bitcoin's layer 1. And within RSK, we're also building something called Lumino, or Riff Lumino, and we consider that to be a layer 3 to the layer 2 of RSK to the layer 1 of Bitcoin. So this will give you potentially like ridiculously high levels of transactions that can compete with centralized systems, such as credit card processing networks, etc. So like you're talking about tens of thousands of transactions per second. So coming soon. Yeah. And next up, we have from Kim, we have a question. With the transition of other blockchains to a proof-of-stake consensus mechanism, after seeing difficulties of proof of work, how will RSK deal with these limitations? Off the bat, I'll say we do not have anything on our roadmap for transitioning to proof of stake, right? Remember that RSK is layer 2 that merge mines with Bitcoin layer 1, right? So in order to change this, we need consensus from Bitcoin miners, specifically 50% or so of Bitcoin miners. And that's going to be hard sell, right? It's a hard enough of a sell on Ethereum, right? I think it'll be even harder of a sell to the Bitcoin to Bitcoin miners to transition from proof of work to proof of stake. So currently, it's not on the roadmap. But I don't want to second guess or assert my own opinion or anything. In practice, what we do have is an RSK IP process, which I mentioned earlier on, RSK improvement proposals. You can go check it out, research.rsk.dev, and that will bring you to, or this QR code, if you scan that, that will bring you to a forum where you can discuss RSK IPs, and we have a call to discuss any RSK IP proposals and announcements if they have been accepted every month or every other month. Yeah, so a proof of stake or any other consensus algorithm change, right, would need to go through this process. So I highly encourage you to check out that forum. And I think, yeah, that's the last question.
Super. So congratulations, guys. We're going to be distributing those Riff tokens to the question askers. So give us a couple of days to get that done. But thank you very much for the high quality questions. So we have about 10 more minutes in the program. So I'm going to open this up to questions. Brendan, I think you could stop sharing the screen and then we'll just make this a conversation. So guys, at the bottom of your screen, you have reactions. Put your hand up if you have a question, then I'll ask you to unmute and Brendan will get to your questions.
Okay, so we've got a couple of questions from Facundo.
Yeah, we could start from the chat. So Brendan, if you want to pick one from the chat, and then if there's anyone here who would like to ask it live, go ahead and put your hand up.
Yeah, I'm just reading through them. Okay. The second question, what kind of cryptographically verifiable zero-knowledge proofs are going to be available out of the box to integrate with self-sovereign identity? Okay, so there's two parts to that question, right? You can implement zero-knowledge proofs on RSK. Like you could use Socrates or one of the other Solidity libraries, and they should work just fine because of the VM level compatibility. So you can do that. The second question has to do with self-sovereign identity, and we have something called Riff identity, which is essentially I would say a service that allows you to implement self-sovereign identity that is tied to your RSK account or your address. So you can say, hey, this is my RSK address. You can make a number of claims about it, such as your name, what is your email address, and what is your phone number, and then you can get it verified, and other people can verify or trust particular verifiers of it, etc. So we have that system set up already. What we don't have is an integration between the two. So we haven't got a zero knowledge proof integration together with self-sovereign identity. So in terms of out of the box, I would say we don't have one yet, but the building blocks are there. Hope that answers the question. All right. Okay, let's see. What was the first question? When using decentralized storage or hosting, what mechanisms will be in place to defend against denial of service attacks? Okay, I guess this isn't really too much to do with RSK, more of decentralized technology in general. So the most popular in the blockchain space I've seen, the most popular decentralized storage or hosting solution is IPFS. And a common pattern that you have is when you have to store a large amount of data on chain, instead of storing it on chain, you store the hash of that data on chain. And what hash do you store? You store the hash of whatever decentralized storage hosting solution you have. So for example, you store an IPFS, the big file, and then you take the hash, which is of limited size, and you store that hash inside your smart contract. And that's the solution that a lot of people go with, right? But that means that your on-chain data, right, is reliant on something that exists off-chain. And yeah, that could go down, right? It's these other things that are not on-chain can be taken down. So a very good or common, I would say, misstep, right, is to upload stuff to IPFS and hey, it works, great, I'm storing the hash, great, it's on a smart contract, and then the IPFS hash disappears because you didn't pin it or you didn't pay someone to pin it. So in that regard, we actually do have a solution, right? It doesn't directly answer your question, but we do have something called Riff Marketplace, in which you can hire a service. You can pay RBTC or Riff tokens and say, I want you to pin this IPFS hash for me, and I'll pay you X units of tokens per gigabyte per month, something to that effect. And then you just pay. It's all in smart contracts, and it's all, at least the economic incentive is all on chain, so that it gives you some sort of assurance that you'll be able to participate in this storage hosting solution without having to go through some centralized provider. So that's one aspect of it. But in terms of denial of service, I don't think there is one that RSK specifically provides or Riff specifically provides to protect against that. You'd be relying on the mechanism that is specific to that particular decentralized file storage mechanism. So, the fact that IPFS is decentralized and has such a big network, etc., so you get some sort of protection against denial of service, right? So, for example, if you take down one particular IPFS gateway, you can always use another one, that sort of thing, or you can run your own node. So that helps to defend against denial of service. But that's not really something that the blockchain does, right? That's something that's that's specific to the decentralized storage solution or provider, the technology. Yeah. Cool. Okay, Danette has a question. Let's see. Okay, not so much hand-holding, I would say. That was a very quick blitz through. But yeah, if you're interested in a more hands-on, step-by-step approach to what you just saw with the SVG animation that's rendered on chain and in an NFT, then well, I guess Mike, gauge the interest, and I'll be happy to do another session that's just focused solely on that one.
Yeah, guys, just follow us on the social media, and make sure if you guys want that, make sure it's we hear you loud and clear. So Zion's going to put it in the chat again, all the links, because I think we got it got spammed out. So Zion, if you could put all the links in the chat for all the social media, then just give us a heads up, and we can organize that if you guys would like that.
Sounds good. Yeah, maybe you could have like a multiple choice, tweet poll or something.
Yeah, let's do it.
Yeah. Or yes, no. Do you want to see this? Yes, no. All right, cool.
All right, Brendan, I think we have time for about one more question to wrap it up.
Question. Okay. Enghu Ihsan, why RSK transaction has higher throughput than Bitcoin and Ethereum? Okay, so one reason for the higher throughput is because the blocks are less frequent, right? So that enables us to optimize the algorithm in some way to make it better. The other reason I would say is that the core engineering behind the blockchain protocol has a lot of optimizations that have been put into it that you don't see in Ethereum or the other blockchains. So there's like, yeah, I would defer to some really, really smart guys who work for RSK in the core engineering team to really give you the true answer to that question. But let's just put it this way. It already had a better throughput by design at the white paper stage, and when it came into practice, that seemed to pan out. So that went well.
All right, fantastic, Brendan. Thank you so much.
Okay.
That kind of wraps up our evening. So everyone, thank you so much for attending. I apologize for a little bit of the craziness in the beginning, but we got through it. And I'll just restate, we're recording this now, so we'll be having this up in the next couple of days on our YouTube channel. So if you guys wanted to come back to it, go through the walkthrough again, it'll be up there in the next couple of days. Those who asked the 5 questions, patiently wait a couple of days. I'll get you your RIF direct to the accounts that you guys set up. And, guys, thank you so much for coming. And hope you guys have a wonderful evening. Thank you so much to Brendan as well. Thank you for doing this.
You're welcome. Yeah, happy to speak to everyone here.